Hello and welcome to another creative coding video. Today we're going to make an interesting little program which will act like a paintbrush drawing program. The idea is to be able to construct an image made of strokes that look fairly realistic, little brush strokes made of individual lines that might have come from a real brush with all its hair. We're going to be using an image that we're going to use as a reference, almost to paint over in a way. So we're looking at a very famous painting here, and it's very kind of delicate and smooth, and we're going to kind of make a rougher, kind of more textured, more action kind of version of that. So that's the idea today. We're not going to be learning anything very new. Most of the ideas we've already covered before, so in some way this project is familiar revision. There are one or two new things, and they're about how to work with images, so we'll learn how to do that. So yeah, this is going to be quite nice actually. The code won't be very long, and yet the effects will be quite interesting. So yeah, let's crack on. So I'm logged into Open Processing as usual, and I've got my Simple.js library turned on, and I've got my simple setup, and I've set my background to white. Let's first try and load an image that we might have saved as a JPEG or a PNG, and see if we can kind of display it. That will be the basics of working with images. And there are a few ways to do that, but one of the most common ways to do that is to load the image up ready for use before the usual functions are run. Because you can imagine that if you've got a large image or it's taking a while to kind of pull in, you don't want the program to run ahead while the image hasn't loaded. So there is a special function called preload, function preload, which is run even before setup. We've always thought of a setup as the first thing that's run, and then draw is run afterwards, either once or many times. But in case there's something that we need to have ready even before setup, we use the preload function. So let's first load the image up from our computer into Open Processing. And you'll have seen this this kind of set of menu options before. This is where we pick our libraries. You might have seen, the editor section for changing text size and so on. There's a little tab here called Files. If you first create a sketch, it won't let you upload a file. You'll have to save the sketch first, and then it lets you upload an image file. Reason for that is, if you haven't saved a sketch, it doesn't know where to put that image. So let's click select, and there's an image on my computer, Pearl earring, which I'm loading up, and it'll take a second while it goes over the internet up to Open Processing, and there it is. Great, so let's load that image. We can call we need a variable name to point to the image. Let's call it img for image. Img equals, and the magic instruction is called load image, and then we give it the name of the image. Now, what was the name of the image? Let's go back and have a look. Pearl underscore earring. So let's type that in. Pearl underscore earring .jpg. Now this variable isn't actually created here. We need to think about where we create it. If it was created inside preload, it wouldn't be visible in setup or in the drawer where we really need it. So we need to create it outside as a global variable. So we say var img. We don't need to assign any value to it like 5 or apple or anything like that. We can just say create that variable, we'll fill it in later. And because we've created it outside the functions, it's a global variable. It can be seen from any function. Great, so when this code runs, it'll create the image variable, preload will run and get filled in with the image, and then we can draw it. And to draw the image, we simply say image, and the name of the image, or rather the variable, and where to draw it. So let's draw it in the top left hand corner at 0, 0. If we run that, hopefully that should work. There you go. So we've got an 800 by 600 canvas. The image happens to be 400 by 400. I deliberately chose a square, it's just easier to work with. And it's drawn at 0, 0, so the top left corner is at 0, 0. Fantastic. And you can do other things, like you can scale them, so you can say, instead of 400 by 400, I want it to be 200 by 200. And that'll make it a little bit smaller. And you can do things like repeatedly draw it, so we can have a loop like for var x equals 0, x is less than 800, x plus equals, I don't know, shift it along by 190, just less than the 200, so it overlaps a little bit, and we're drawing it at x across and say 200 down. That should repeatedly draw the image along a line, as it were. Let's have a look at that. Lovely. That's rather nice, actually. I like that. That could be a poster or something. There's something nice about this arrangement. I don't know what it is. I like it. Fantastic. Brilliant. Okay, so we've worked with images there. We know how they work. The next thing we want to think about is how to draw brushstrokes that follow the mouse pointer. So the mouse pointer is this thing that we move when we move our trackpad, or our mouse, or our pen if you're using a pen. Luckily, there are a couple of variables called mouse x and mouse y, which are automatically filled in by P5JS, and they're always the values associated with where the pointer actually is, and they change when you move the mouse pointer, so whenever we use them, read them, they're always the right answer, and if we read them again, they'll be the right answer if we move the mouse. So we can say, I don't know, just draw a circle at mouse x, mouse y, size, I don't know, 10. If we do that, actually we need to get the loop going. Do you remember the loop for repeatedly calling draw? Because if we didn't do that, this will be called just once and that'll be the end of it. With loop, draw is run again and again and again. So if we do that, we should get, there you go, circles being drawn where the mouse is, where the pointer is. You might not actually be using a mouse. It's a slight delay, but that's okay. Computers they go fast, but not that fast. So that's great. So we now have a way of knowing where the mouse is, and then we can use that information to perhaps draw a line. I don't know, mouse x, mouse y, and then we can say, well, actually, let's do that properly. Let's say var x is mouse x, var y equals mouse y. And let's actually call that var x1 and x2, because we're going to draw a line from where the mouse is to just a little bit away from that. So we can say x2 is x1 plus 5, say, and var y2 is y1 plus 5. And if we draw then a line from x1, y1 to x2, y2, that should draw little lines which might not be a realistic brush yet, but it's the start. Let's tidy the code a bit. Have I done something wrong there? Yeah, that's right. Let's run that. And there you go. Little tiny lines which together could be a basis for drawing a brush stroke. They're all in the same direction, aren't they? So let's maybe randomize that a little bit. Random number, I don't know, 2 to 10, just as an example. So it's not realistic yet, but we're just experimenting to see whether little lines slightly randomized in direction can start looking like a brush stroke. A little bit better. They are not all pointing in exactly the same direction. And the next thing we can do is introduce a bit of transparency, because they're all looking a bit saturated. So let's give ourselves a blue, red, green, blue, a blue colour, and give it a bit of translucency. Then you can see there, if I don't linger over a place, the colours are not too dark, but if I then hang around one place, the colour builds up. Can you see? So that's a little bit more realistic in how, you know, we can build up colour with a brush stroke. Still not ideal, I think, in terms of the imprint made by this brush, but it's a good start. What else could we do to improve that? Well, what we could do is use noise, because do you remember in Perlin noise from the earlier tutorial? It's random but not so random, and randomness nearby follows a similar kind of direction, and that's useful for laying out where these brushstrokes go. So let's replace randomness with noise. If you need a reminder, I really recommend going back to that video. There's so much kind of content and ideas in that video. I really recommend you kind of do that and learn about kind of Perlin noise. You'll understand why it's so useful. So let's say noise based on where we are. So x1 divided by, we're scaling it if you remember, y1 divided by 50, and that gives us a value between 0 and 1. So let's take 0.5 from it, and then we have to scale it, so let's multiply it by, say, 50. Otherwise there'll be really tiny little brushstrokes. And this one will make it y1 and x1. Again, have a look at the video on noise to understand why we've done this. So let's just reiterate what we've done. We've got mouse x, mouse y, which is where we start our line, and then we're going to draw the line to a not entirely random point near the start of the line, a point dictated by noise, so it's calmer, more smoother randomness. Let's give that a shot. Okay, so yeah, some of the lines are big, some of them are small, but nearby the small it remains small, and that's the property of noise, and near the big they remain big, and the directions are kind of aligned as well. So that's kind of nice. And this is what noise, this is what noise is. Can you see what's happening there? So there's a little bit more order now, and you can see how this looks like a sort of a hairy surface now, doesn't it? Maybe we can just paint a kind of a creature with hair. But it's a really nice property of noise, isn't it, that we can have a smoother randomness, and the good behaviour of noise helps us here. So just to repeat, when it's a small offset, all the points like this are small. If it was entirely random, it would be a chaotic mess. Where they're big, the neighbourhood is big as well, and the direction they're pointing in, kind of, they flow along each other, which is really helpful, again, to avoid sort of a chaotic picture made of brushstrokes. That's lovely, isn't it? You could just stop there, but I won't. So this is a basis for starting to put down some brushstrokes, but the colour is blue here. Let's see if we can get the colour from the image. So we're not going to draw the image, but we're going to refer to the image. So let's kind of talk about what we mean by that. So here is just a kind of a picture I've drawn showing the canvas 800 by 600, and there's an image here like portrait. It happens to be 400 by 400, but it could be something else. Now the image variable has parameters that come free with it. Image.height is the height and image.width is the width, and they get filled in when we load the image. What we want to do is, if it's sort of brown here or black here or green here, that's what we want the colour to be for our little hairy brushstrokes. So we need to query this image and find out what the colour is at that point. That means we need to convert, or to get the location in the image, which starts here, the top left, and then X there and Y there, we need to convert from canvas coordinates to image coordinates. So the canvas coordinates go from 800 to 600 down, 800 across 600 down, but the image is smaller. It's 400 at the moment. It could be something else if we used a different image. 400 across and 400 down. So we need to convert that. So just to give you an example, 400, 300, which is the middle of the canvas, 400, 300 in canvas coordinates is in the middle of the canvas. To convert that to the middle of the image, that would be 200, 200. So we need to do that kind of conversion. And the trick, if we want to center the image, the thing to kind of recognize is we could map from, we can use the map instruction. We've used that before. Remember, map converts from one range to another range. So we can convert from, say, 0 to 100, like percentages, to a fraction like 0 to 1. So if we had 50, you would convert it to 0.5, and that's what map does. Again, have a look at the previous tutorials. And what are we converting from? Well, we don't want to convert the entire canvas. We want to convert from just where the image is going to be. And the trick to recognizing the ranges is to say, this position here is half the canvas width minus half the image width, and this position here is half the canvas width, which is 400, plus half the image width. So that's the range from half the canvas width minus half the image width, all the way up to half the canvas width plus half the image width. Blah. Sounds complicated, doesn't it? And the same downwards, the range is going to be the same sort of expression. So once we've done that conversion, we've got coordinates for pointing at the image. Let's do that first before we go any further. Just going to tidy things up a little bit here. So we want the image coordinates, let's call it IMX, and image Y, IMY, is a map of mouse X. We don't need to create an X for that, we can just call it mouse X, which comes from the range half the canvas width, which actually happens to be width. That's another magic variable that's filled in. We could have said, I don't know, 800 divided by 2, I mean, because we know what it is, but let's use the generic in case somebody changes the data. So width is always the width of the canvas over 2 minus the image width divided by 2, and then going up to that's the starting range from there to there, and now we're getting to the target range, which is from 0 to the image width. Actually, that might be image width -1, because if we've got a 5 by 5, actually we've got a 10 by 10 image, 10 pixels by 10 pixels, the numbers we want go from 0 to 9. So let's do that. And a similar expression for y. So those are the image coordinates. So those will go from 0 to the image width -1, and then the height, we're doing this vertically, height. Great, so we've got the image coordinates. Now we need to query them. Get color at IMX, IMY of the image. How do we get the color? So this is one area where I think P5.js could do better. It's often useful to be able to query an image, even if you've not drawn it, and get the color at a certain coordinate. They help us already by getting the width and the height, but I think that's maybe something they'll do in the future. So unfortunately at the moment we have to kind of access the memory that the image is stored in and pull out the values ourselves. So let's write a function to do that, because it's a few lines of code and it will just make the main draw function a bit untidy. So for now, let's say we'll need red, green and blue for the values that we're pulling out. So we could say var red equals something, var green equals something, and so on, var blue. 3 lines, but actually there's a nice shortcut that modern JavaScript gives us. We can define them in one go. We can say red, green, blue is something, like we could say 1, 2, 3. So this list of 3 values becomes that one. So red becomes 1, green becomes 2, blue becomes 3. That's neat and kind of tidy. We don't have to have 3 lines to define red, green and blue. So our function needs to return a short list of 3 values, the red, green and blue values. So let's call that function something useful, like let's call it get RGB from image, and we need to pass it which image we're interested in and where IMX, IMY, that's the location in the image that we're interested in. So let's write this function now. So function, define it there. We can use the same variable names here, they won't clash. In fact, let's tidy that up just to no, that's fine actually. IMX, IMY, still intuitive. Right, so we need somehow to use X, IMX, IMY, image Y, to pull out the red, green, blue values from that image. Now how do we do that? Well, before we can do that, we need to ask P5.js to kind of create an array of values that we can access. It doesn't do that by default, because to display an image it can just kind of do that without creating that kind of array for us to use. So to do that, we need in our setup to say we can say image. So let's write a comment so it's clear. Create array from image, and so we say image, which is already the variable, dot load pixels. That will create that image array for us to query, and it will be the pixel values really in red, green and blue. Let's draw a picture to show what we mean. Okay, so imagine we've got this four tiny, imagine this is a tiny kind of image, 4 pixels by 4 pixels. It's really tiny. I could carry on drawing all the pixels, but I won't. Now, you would expect to be able to say something like get color at, I don't know, X and Y to be able to get the color. Unfortunately, as I said, P5.js still hasn't made that easy, and in JavaScript there isn't a native two-dimensional array like some other languages, so this kind of structure, this kind of two-dimensional grid of numbers of pixel values is actually stored as a long list. So even though it's 4 by 4 here, it's actually unrolled as a long list of just numbers one after another. So if we wanted this kind of pixel, top left, it would be this first one. But actually it's not just that, there are red, green and blue numbers there. So the first number would be red, the next number would be the green value, the next number will be blue, but there's a fourth one which is transparency. So we have red, green, blue, and it's called the alpha value. So the first 4 numbers are for the first pixel, red, green, blue, alpha. Then the 5th number starts with red again for the next pixel. So how do we convert X and Y to just an index into this list? So the way to think about it is to say, first of all, which pixel are we, which box are we interested in, and that's the image width, let's call that image width, times the Y value, let's just call it W there, W times Y, width times Y. So if Y is 0, we're in the first row, if Y is 1, we're in the second row. So let's look at this pixel here. So Y is 1 and X is 0. Y is 1, so 1 times width is 4. So we want 0, 1, 2, 3, 4. So we're in the right place. But then we want to add to that kind of starting point whether we want this one or this one or this one or this one. So we then say W times Y plus X. So let's look at this one, for example, which is at X is 0, 1, 2 and Y is 0, 1. So Y is 1, 4 times Y, 4 times 1 is 4, which gets us here, plus X, which is 2, 1, 2. So that's 4 plus 2 is 6. 0, 1, 2, 3, 4, 5, 6. 0, 1, 2, 3, 4, 5, 6. That's the 6th cell. Index 6, sorry. Which is the 7th cell. Index 6. But within that, we need to pick out the red, green, blue, or alpha. So we multiply all that by 4, because there's 4 of these. So there's 3, 4. And then that will be the red. If we added 1, that'll be the green. If we added another 1, 2, that'll be blue. If we added 3, that'll be the alpha, but we don't need that. So let's rewind that if you need to. That's a little bit kind of slightly complicated, and I do wish P5.js made it easier. Maybe I'll put it into the simple library, I'm not sure. Maybe I will. But that's kind of the arithmetic and the explanation for the code we're going to write. So we say let's var red equals, we said it was for the width, so it's image dot width times y plus x times 4. So let's do 4 times there. That's going to be the index into the image there, and then the other ones, green and blue, are just a little bit, just one added to those. So green is the next one along, and then blue, if I can type blue, is +2. And I'm going to return a little list, as we said, of red, green, blue. Hopefully that'll work. So if I do that, I can then say my red, green and blue is set, and I can say stroke for setting the colour of the line, red, green, blue, and then I can draw a line from, I don't know, for now just say mouse X, mouse Y. Let's just draw a circle for now. We'll fill that in later. Is this going to work? Is there any error we've made? There's a tiny error. This is a list that we're querying. Do you remember the list of pixels? So the index into the list has to be an integer. Just tidy that code up. But what we are getting here is not an integer, because map can give you a fraction. It could be 7.5, it could be 2.29. So we need to wrap that in as an integer. So code's getting a little bit long, that line. I could have put that on a new line, but it's small enough. And we also need to constrain it so that when the mouse pointer is not corresponding to where the image is, we don't want to kind of pick up values. Otherwise, image X and image Y could be negative, or could be kind of over the edge of the image. So we need to constrain it. So we can say image X is constrain. That's a new instruction I've not seen before. It's a bit like minimum and maximum together. So we're constraining image X to be between 0 and image width -1, which means if it's more than that, it'll become image width -1, and if it's, say, less than 0, it'll become 0. And we can do something similar for image Y. Constrain image Y to 0 and image height -1. Hopefully that should work without any errors. Let's try it. Oh, I did make a little typo. Line 32. Y is not defined. Oh yeah, that's the error I've made. It's not image X. Just change it here. That'll be easier, won't it? There you go. Let's run that now. Oh, I forgot to. I'm using stroke there. It should be fill. It's not picking up the image values. Now, why is that? Okay, I know what the error is. I made a little error there. It's image.pixels. That's the that's the problem with trying to do it all from memory. It kind of leaks out of your brain. So it's image.pixels, not image, that we pick the values from. So image is the image, but image.pixels gives us access to the pixel values. Let's try that, see if that works. Yep, that's picking up those circles. they've got black outlines, you can't really see them. But let's turn those to lines now. Line, mouse X, mouse Y, and just for now we'll just say mouse X plus 5, mouse Y plus 5. There, that's picking up the colours from the image. And you can see the skin tones in the middle, bit of a black outline there. Fantastic. Great. So we successfully picked up colours from the image and used that colour for our brush. Now let's refine our brush now. Okay, so we've got the colour. Now we want to draw a line from X and Y to another X and Y, don't we? Let's have a little think about how best to do that. Let's work backwards. We'll say X1, Y1, and X2, Y2. Working backwards here. We know that X2 and Y2 is based on adding noise to X1, Y1, so we can say var X2 equals X1 plus our earlier expression that we developed. So it's noise, and we said it was X1 divided by 50, Y1 divided by 50 minus 0.5, and then multiplying that by 50 to scale it up, and then doing something similar for Y2. That's just what we did before. So we've got the adding noise bit, we just need to know what X1 and Y1 is. Well, it's the mouse, isn't it? Mouse X, mouse Y. So var X1 equals mouse X, and var Y1 is mouse Y. Is that right? Is that what we want to do? Sometimes you can kind of doubt yourself and think are you doing the right thing? Let's give it a go, see what happens. Yeah, I think it is right. Yep. There's no reason to doubt. So there you go, we're picking up colours from the image and we're drawing little brush strokes. But we can make them more realistic, I think. So we can think about the width and the see-throughness, the translucency. We didn't do that, did we? So we'll go back to our stroke instruction, which gets the red, green, blue from the image, and we'll add a translucency, which I think will help. Yeah, it's adding. So if we hover over something a lot, the colour builds up. I think we can also do something about the thickness of the line. Let's do something with that then. Stroke weight. What should we make it depend on? Let's make it depend on the red, green and blue values. So if we said the red, green, blue values are high, that means the colour is lighter. And we want to map that somehow to being quite thick, I think. Whereas if it's dark, maybe I want that to be thin. Well, let's experiment, see what happens. So we want to map. We're using map inside here now. Map. We want to map red, add green, add blue. We're adding them together, which goes from 0 to 250 to 5 times 3. That's the potential values, the range of red plus green plus blue. Remember they're 0 to 255 each. And we want to map that from well, actually no, if I want the dark areas to be quite thick, so if I say that goes from stroke weight 2 down to 0.1, so it's never 0, it's just at least a minimum 0.1. Let's see what effect that has. Okay, so it's not a massive difference, is it? Is that actually changing the width there? So that's mapping the sum of red, green, blue. Ah, I did that wrong. So we're doing mapping red, green and blue. And put the brackets in the wrong place. There you go, that should work now. There you go. See, so when it's dark, black is thick, and when it's light, very thin, so we can focus more on the details. That was my reason for making it black out here, kind of thick to fill colour. But here, the line's really quite thin, isn't it? And you can start building up much more detail. They're still not realistic brushstrokes. So do you remember when we had lots of, actually, yeah, that's a good way to do it. Let's repeat that bit of code that draws the line, but we don't want to draw over itself. So what we're doing, we're saying all of this we want to repeat and jiggle the coordinates a little bit, just to otherwise we'll be repeating it and drawing over each line exactly as it was before. So let's put an outer loop around. So we're saying for, let me explain in pictures what I'm trying to do. So we're drawing a line, and if we want our brush strokes to be a little bit kind of like, I don't know, like that, instead of just like that, then this might be a bunch of, say, 30 little lines, but they can't be exactly the same. That means for each of them we jiggle X and Y just by a small random amount. That's what we're trying to do. So we say for I don't know, var I counter is 0 to, let's say we've got an experiment card, we can say I is less than 30, I plus plus, and then we're repeating all that code that we've just developed. So let me indent all that. So all that will be run 30 times, but we don't want to draw each line over itself 30 times, so we jiggle the image X, image Y a little bit. So do we want to do that before or after the constraint? We want to do that before, don't we? So we can say IMX plus is random number, let's say minus 5 to 5. So we're jiggling it a little bit. IMY plus equals random number between minus 5 and 5. So that will just shake it a little bit. Let's try that. No, it's not really doing that, is it? What error have I made? Okay, I've worked out what my error is. I'm drawing the lines from X1 and Y1, and that's not affected by jiggling the image X, image Y. So I could actually do this. we can just add some jiggle to the there you go, so I'm adding the jiggle to the right place. Let's see if that improves the drawing. Yeah, that's much better, isn't it? Look at that, really cool. Much better. Do I need to tweak the size of that brush? Is there too much there? Maybe if I reduce the number of strokes to say 10, does that, see what effect that has? Thinner brush strokes? Yeah, that's kind of nice. Yeah, I like that. I could, yeah, I don't want to go on too long and refining it. You can refine it yourself, but you can certainly see how now it's picking up the colours from the original image, and we're definitely drawing strokes here, aren't we? And they definitely have got a brush-like quality. I mean, we're never going to have something super realistic in such a short program, but the main idea has come through, hasn't it? There you go. Actually, I'm not 100% happy with the details, the way it's handled. So maybe I can have another think about how to... It's too mushy, isn't it? Yeah. Let's have another think about how to do that. Yep, I'm going to try mapping back. So I'm deliberately going to keep the jiggle in the image X, image Y, so it's kind of jiggling a little bit where it picks the colours from, and then I'm going to map back to from image X, which goes from 0 to image.width -1, and I want that to go in the new range, which is half the canvas width divided by 2 minus image width divided by 2, and then the other one, the other extent of that, which is the plus, and then something very similar for all that of that. Oops. For image Y. Great, let's see if that has a effect. Yeah. It's nicer, isn't it? Nice little swirls there. Let's see how it picks up some of those details. Yeah, I like that. It's looking sad over there, isn't it? That's just where the noise swirls went, I guess. You could always make the brush strokes longer and shorter. You can do that by changing the 50 that we multiplied noise by to something that's bigger or smaller. You can change the number of little lines in each stroke from 30, which is what I had it, to something else. That looks really sad. Let's do another one. She looks a little bit sad there. Let's see if the swirls are a little bit more promising here. She looks a bit more thoughtful now. But you can, I love the detail that, you know, this creates, the brush strokes. That's really nice, isn't it? Because we're using translucency, it kind of adds up, doesn't it? The effect. Wow, this is really nice. Yeah, you could carry on doing this. I won't go on too long. Just revealing enough of the image for us to kind of get a sense of how it works. That's really nice. Let's get more of the black around the edge there, and some of the headdress that's going down the back. Now, we could do more interesting things, obviously, where the direction of these brushstrokes follows the image a little bit. You know, we'll have to think about how to do that, how to calculate where elements in the image are kind of flowing in some sense. But that would make this lesson, this kind of tutorial, quite long. There we go. Try and fill in some of the lines there. That's nice, I like that. Just do a... Cool. Brilliant. What I will do is just to add a nice decorative touch, which is just to give a nice little outline, a framing to that picture, so we can add like a little border, which unfortunately will get drawn lots of times because we're using loop on the draw function, but that's okay. We can say no fill for drawing a rectangle, stroke 0 to make it really thin, and then we can say stroke 0 to make it black, stroke weight to make it not too thick, and then draw a rectangle from where do we want it? We don't want it around the canvas, we want it around the image. So we could say width over 2 minus image width over 2. That'll give us sort of the left hand extent of the image in canvas coordinates, and then extend that by 50, and then do the same in the other direction. So we say height and image.height. Over 2 there, and then that's the top left of the rectangle. And what's the size we want it to be? The image, the full width, plus 50 plus 50, which is 100, and image dot height plus 100. Will that work? Oh yeah, that's nice. It gives it a lovely framing. I'm glad I did that. Sometimes you have to think of like that kind of finishing, as it were, the decoration or the framing. Are we going to end up with a sad looking face again? It really depends on where the... Oh, that's okay. Actually, I think I will restart that. I can't control randomness. Right, let's see. The eyes are so important, aren't they? What they're doing really defines the face. Lovely. It's like dabbling little paintbrushes. Oh, that's turned out really well, hasn't it? Nice. That's it, just filling it around the edge to give it a bit of a shape around the head, so it's kind of contained. Lovely, look at that, it's emerging now, isn't it? finish off the headdress a little bit more. Look at that. It's such a simple idea and it's become quite effective, hasn't it? Yeah, we're not really using mathematics in the sense of getting it to construct the main elements of the image, but we're using a pre-created sort of photo or picture, but we are using noise and mathematics to create the brushstrokes and the directions that they're moving in. So that's kind of lovely, I think. If I had more time, without making the video too long, I might make the outer dark areas perhaps less dark. I think they're a little bit overly saturated there. Lovely. Look at that. I'll stop there, I think. Fantastic. I'll put the code up for you to have a look at as well. But I hope you've enjoyed that. What we've done is brought together things we've learnt before around coordinates and noise and the map function, and we've combined it with a little bit of new knowledge about how to load an image and how to query it in terms of picking out colours from it. And we've made, combined that to make some interesting kind of brushstrokes. And this is just the start. I mean, this isn't refined in any way. You could spend a lot more time making it more realistic in terms of the brushstrokes. But you could spend weeks doing that. But the core idea is here. So I hope you've enjoyed that. Yeah, well done, and see you again next time for another video. Bye.